think you square rooted for that. And I think you square rooted in geometry when you did the distance formula. Yeah, so I know you square rooted before. But we'll talk about some important aspects in square rooting, solve quadratic equations in algebra 2. I have some notes here just to get us started on the right foot as we approach these three questions. Before I get into it, does anybody have a question about the schedule for the day? At the end of class, you will have a short Bellward quiz. It's only 5 questions. So, the first period seemed to do really well on it. So that's why you have Chromebooks, just for that. So we're going to do these 3 questions, then we're going to go over yesterday's graphs, look at those, and then pretty much after that will be the Bellward quiz, and you guys will start your assignment, which is 11 through 18. Okay, so when it comes to square rooting, always isolate the squared term before square rooting. So whatever is squared should be alone before you hit that square root button, or before you draw the radical. Okay? The other thing is, you're supposed to think about 2 possible answers when a variable is squared. For example, x squared equals 25. What do we think x is? Well, x is definitely 5 because 5 squared is 25. But x could also be negative 5 because negative 5 squared is 25. So there's 2 answers because there's 2 things that can square to be 25. So the way we show that in algebra 2 shorthand and in higher math is we would say x and we put a positive and negative in front of the 5. So we stack those signs up. So what this means is that there's 2 answers. X is a positive 5 and x is a negative 5. Okay? And that tracks really well with square equations being parabolas, because parabolas tend to, not always, but tend to have 2 intercepts. So when you think about it being positive 5 and negative 5, that goes along with the reading we did yesterday about roots, solutions, and x-intercepts. So the positive and negative 5 are the 2 x-intercepts for the parabola. So it makes sense that there's 2 answers because a parabola has symmetry. It makes sense both mathematically when we plug it in, and then that tracks when we look at the positive and negative solutions for x in the problem. So let's get into this number 1. How do we solve it? So yesterday we were graphing to find x-intercepts. This is kind of the same thing, but we're not graphing, we're solving using our algebra skills. I think I wanted to write this on the screen actually for a moment. When I look at 10x squared equals 90, it's just the x that's being squared. This would almost better be written as 10 times x squared equals 90. Okay, the 10 is not being squared. So I would say that this rule here, that the square term needs to be isolated, needs to come into play here, because right now it's 10 times x squared. X squared is not isolated. We're going to cancel it out. So I would divide by 10. And 10 over 10 will cancel. and x would be 3, and I'm going to use this, I'm going to write this the more advanced way. I'm going to say x could be positive 3 or negative 3. So some students would really prefer writing it out like this, like showing both the positive and the negative. And then some prefer this way. Now the SAT and higher level math classes, they will just jam those symbols up together instead of writing them separately. Here's number 1. Number 2, you're pretty familiar with 8. Square root of 64 is 8. Square root both sides. Show your work. Write the square root bar. And we have x is plus and minus 8. Because 8 squared is 64, and negative 8 squared is 64. Now number 3, the really tricky one. We want to move this right here. Ooh, it fits. So with this we're looking at, this actually, I'm hoping part of you is like, wait a minute, this kind of looks familiar. This looks a little bit like vertex form. Okay, vertex form is x minus h squared plus k. If I were to subtract 36 right now, I would have this. And then that's similar, or if we were to graph it, we would put a y in, and I would have a vertex at 5, negative 36. So the way this looks here is going to come up a lot when it comes to quadratics, because this vertex form, it's a really useful form of the quadratic equation. So being able to solve it from here is handy. I can already picture the graph, right 5 and down 36. Where are the x-intercepts? If I solve this, it's going to tell me x-intercepts. So I don't see anything in front of the parentheses or to the right of the parentheses. Everything here is getting squared, so this is isolated. So let's do a great big square root bar. And putting a square root bar over a power of 2 just cancels it out. They're opposite. It's like adding 5 and subtracting 5. Cancels. So cancels. You no longer need the parentheses. You can remove the parentheses. And we get x minus 5 equals plus or minus 6. The square root of 36 being 6.
You want to keep solving?
Yeah, I'm going to keep going. Yeah, so this isn't done. From here, because this one's longer, has this minus 5 situation. Yeah.
Would you add 5 to positive and negative?
Yes, so now it's like we have to do 2 different problems. So I recommend for work purposes that you now separate this. Because you have to do it in both places. So we're going to separate this into 2 equations. We're going to do x minus 5 equals 6 and x minus 5 equals negative 6. So you can solve it by adding the 5. And we get x equals 11. Add the 5 here. And we get x equals negative 1. Two answers, and they're totally different. Before it was plus and minus 3, plus and minus 8. These are way different numbers. Okay? Now, I tend to question that. Like, How do we know this is round? So the great thing about solving equations is that you can always check it. So whenever you question it and you wonder, does this check out? You can just plug in and you can determine for yourself, is it true or false? Does 11 really work and does negative 1 really work? So I'm going to put 11 in here and check it out. Is 11 minus 5 squared equal to 36? 11 minus 5 is 6, and 6 squared is 36, so that works. 11 I definitely agree with. Now I'll try negative 1. Is negative 1 minus 5 squared equal to 36? Is negative 6 squared equal to 36? Yes, it is. Both of these answers work. So now I know the x-intercepts of this parabola.
Oh, it's because
The axis of symmetry is 5. It's way down here at negative 36. And I have two x-intercepts. One is at negative 1, and one is at 11.
where did there?
Well, if you move the 36 and make this equal 0, and then 1, the vertex is 5, negative 36. And now I have the intercepts at 11 and negative 1. And there should be some sort of like sometimes people prove this using midpoint formula. The midpoint between these is the center of the parabola. So it's 12 units in between here. So each one of these is 6 units from the middle. There's a lot that we can tie together when we look at the intercepts and vertex form. So that's today's work, solving by square rooting. Let's look some more at those graphs from yesterday. So open your books to page 189. Sorry, about it. I shouldn't have to move these yet for the rest of the class. Okay, the books in the bottom shelf have them. Try to remember to get your answer pages, but it's all of chapter 3. We did 1 together in 3rd period, or did we do 4 together? We did 1 together. Let's look at number 2. Okay, my problem's a little faded. So it's negative x squared plus 2x plus 3. So in number 2, your axis of symmetry should have been positive 1. And then when you plug positive 1 in, you get 4 out. If you got 1 for your axis of symmetry and you plugged it in, you didn't get positive 4 out, that's a quick fix. You just need to ask. I'm plugging in 1 and I'm not getting the right answer. What can I do differently? I can show you exactly how to put that in your calculator. Or even just do it by hand, get your 4 out. So 1, 4, there is a negative in front of here. So the arrows go down. From there, you can either make a table, or since there's not a stretch or a shrink, it's the same shape as the parent function. So you go right 1, down 1, right 2, down 4. Or you can make a table. So if I were to make a table for this one, 1, 4 would be in the middle. And then 0, 3 is here, so you can reflect it. And then you find these. These are the most important parts. The negative 1 and the 3 are the most important parts, the x-intercepts. So I box those numbers. 3 is pretty important to talk about. So, whenever you're ready, we'll have to